LeetCode problem 345. Let's take a look at the problem statement right away. Here basically the conditions are quite simple. We have a string and we need to swap only the vowels in this string. Note here that we're told exactly which vowels we need to swap, so we don't need to change any other characters. Here are our examples. Ice cream. Here we have the vowels that we need to swap. This one, and this one. Also note here that we have lowercase vowels and uppercase vowels. So we need to take that into account in our code as well. And here from our example, we see that I is swapped with A. Like this, and I is swapped with I. Well, since they are the same, basically nothing else. But this doesn't affect the result. It's the same in our second example, LeetCode. So we swap these characters and we swap these characters. That's it. And we get this result, and this result. Again, I want to draw your attention here that we have uppercase and lowercase letters. Therefore, when we write the code, we need to take into account not only the lowercase, but also the uppercase versions of these characters. We've finished the first stage of fishing, meaning we've caught all the keywords, we've realized that we'll be working with strings, and we've understood that we need to use not only lowercase, but also uppercase. We've completed the first step and finished the first puzzle piece. As with all tasks, we follow the same algorithm, so let's move on to the second stage. Let's take a look at the solution to this problem. The first thing we need to do, in general, working with vowels or consonants, or with certain specific characters, is a very common technique when solving problems on LeetCode. So you can make a note of this point for yourself. And as usual, this is how it's done. That is, we simply store the characters we need in a set. That's it, and then from there we can retrieve an element for checking to verify it. And this is a very inexpensive operation, so this approach is very correct and appropriate. That's why you can use not only vowels here but also consonants, certain digits, and so on. Be sure to remember this technique. We create a set as storage and then save all our vowels there. Next, we convert our string, the original one, into a list. Why? Because this way when we work with our string, we can go through each character one by one. And each of them will be processed individually. That's why we convert a whole string into a list, where each character becomes a separate element. We do this in Python using this kind of construction. And next we encounter for the first time a very interesting and extremely common technique, I would even say an incredibly widespread technique, called the two-pointer method. That is, we have a pointer on the left and a pointer on the right. What is this? So for example, we have our word, and here these characters are separated from each other, appearing as individual elements in the list. And one pointer will point to the beginning, to the first element, and the second pointer will point to the end. And we will continue to develop this two-pointer algorithm in other problems. But here we're encountering it for the first time, and it's very simple. So we move this pointer to the right and this pointer to the left, and they move towards each other until they meet. And this movement of pointers towards each other appears in a huge number of problems. That's why, even though this problem is small and in principle everything here can be solved logically, we immediately see two techniques at work. Two very cool techniques. The first technique is that we store some symbols for comparison in a set. The second technique is that we convert a single string into a list to work with each element individually. And the third technique is that we use two pointers. These three techniques are really great, really cool. And in general, basically, if you know these, there's a huge chance you'll encounter these three techniques in an interview. And finally, because our ultimate objective is to return a singular cohesive string, we strategically employ this particular join technique, which meticulously converts our previously generated list of individual characters back into one unified complete string. I've already shown this file, and I've also shown this tool, .join. It allows us to combine our characters A, B, C into a single string, ABC, which will be the result we need. I'll repeat, if you want to get my file with my tips and notes that I personally use when studying algorithms, then follow the links below. Now let's move directly to our logic. The logic here is also pretty straightforward, really. There aren't any super tools here, but there are some points you need to pay attention to. So we start a regular loop, as you can see, and in the loop we begin to move the pointers. So we start moving this pointer to the right, and this pointer will move to the left. Here, I want to point out that when we use two pointers, you should always keep in mind that we need to come up with some condition for when these two pointers move and when they stop. Without these two options, the whole scheme won't work. So inside this loop, we also launch two separate loops. These will move our pointers. Here, it is important to pay careful attention to the fact that we meticulously move these two distinct pointers, specifically the left pointer and the right pointer, quite separately and independently. Consequently, this initial loop, in its general operation, comprehensively covers the coordinated movement and progression of both of these important pointers throughout the entire process. But inside, we need to write another loop that will move only the left pointer to the right until we reach a vowel. So we checked L. No, that's not a vowel. It's not in our list. This character is the one that we have, the one that's present in this list. So this pointer has found what we need. That's it, we've stopped here. Now we need to move the second pointer. The second pointer immediately found the letter I as well. Which ones do we have? In this list right here. So now both pointers are at the positions where they should be. That's why pay attention here. This is the movement of the left pointer and this is the movement of the right pointer. And both of them move until they cross the middle and go off in different directions. That's why we have this condition. The left pointer is always less than the right pointer. This fundamental principle holds true for both of these important pointers. Consequently, the left pointer diligently moves towards the right until it eventually reaches the position of the right pointer, and conversely, the right pointer carefully moves towards the left until it ultimately reaches the position of the left pointer. What happens next? Next, we meticulously check if the current left pointer's value is not present within our established list of observed elements. Then, in such a specific scenario, we simply proceed to move it further along the sequence, advancing its position. If the right pointer is not in our list, then we move it further to the left. So these two loops check whether we found a vowel or not. And here, notice that we're checking with not in. And with this setup, when we check not in, we move our pointer until we find a character that is an exception for us. That is a character that is in our list of vowels. So we keep moving until we find it. Once we find it, we move the second pointer. Next, after these two loops have finished working, as a result, after this action, the two pointers will be pointing to the two characters that we are going to swap. Then we simply swap the characters. Here we check again if our left pointer hasn't reached the right pointer using this kind of construction. Using this kind of code structure in Python, we simply swap them. So as you can see here, we assign the value of the right one to the left one. We assign the value of the right pointer. And to the right pointer, we assign the value of the left one. If you are using some other programming language like Java, Kotlin, JavaScript, it doesn't matter. This construction will look different, but the logic will be pretty much the same. And very importantly, don't forget, after you've swapped the characters, you need to move the pointers further forward. So you move them like this. Move the left pointer one character to the right and the right pointer one character to the left, so that they're facing each other. You see, using this approach, with plus equals 1 and minus equals 1. And with this kind of construction, we go through all our characters. That is, we always start from the left and always from the right. And that's it, and they start moving towards each other, checking each character, validating whether it's a vowel or not. And when we've reached the middle, it turns out that the left pointer has passed the right side and the right pointer has passed the left side. And here it turns out they've crossed paths. That's it, so we can exit this loop because it no longer matches. And in the end, It turns out that all we have left to do is we need to turn our generated list into a complete string and then return it, because according to the problem statement that was provided, we were explicitly told that we absolutely need to return a string as the final output. See? Return it as a string. And in this way, using this simple, straightforward approach, you get the result you need. But as I said, this is a very useful problem because here we used several important tools here, several important techniques. We learned about storing certain characters for comparison, using sets, and converting a string to a list. And we also learned how to work with 2 pointers. As I always say, these are the tools. These are the very tools that you study and will use later on in other problems. So make sure to practice these tools that I showed you. Let me now show you in the logs how it all looks, so you can clearly understand how it works. This is what the logs look like. For example, let's say we have a word like hello. And we have a list of characters like this, which we will use for comparison. Here we have the left pointer pointing to A, the second pointer is on O, and that's why our left pointer moves, as you can see, because after checking, we see that it's not in our list of vowels. Next we move the left pointer and we find the letter I. Both the letter O and the letter I are in our list. In this list right here, and that's why we swap their positions and then we move both pointers further. We move the left pointer to the right and the right pointer to the left. So as we keep moving along, apart from these 2 vowels, we basically don't have any more. That's why the result is returned as a string. Now I can comment out this code, and for example, we can uncomment another part, for instance this one, and run it as well. Here we have more vowels, but they work according to the same principle. That is, as you can see, we move the left pointer until we find this first I. Once we've found the first and the last I, we swap them. Then we keep moving forward. And here on the left we have, and on the right we have D, so D doesn't fit, we move further. But when we have I and all, that's when this I gets swapped, right at this all character. And in the end, we get this kind of result. Again, these are logs that I wrote myself, and I'll say this again from my own experience. When I wrote out each piece of the blog like this, the task settled in my head much better than if I had simply solved it on the LeetCode. I also frequently write various detailed notes, comprehensive examples, and so on for myself here. And so, as I always say, it's much easier to process and organize everything in my own head. All of this gets memorized, so I recommend to everyone. If you want to get my notes on solving problems, which I solve with all these logs, just run them on your own computer and take a look. Just follow the links provided with this video.